All right. Good afternoon, everyone.
Good afternoon, sir.
All right. I hope all of you are in healthy condition, so we can study in focus today. All right. Before we start our lesson, as usual, let's pray. Pray begin. Bismillah. Amin. All right. 18 students already here now. One student missing. They must still here. Not here. Yeah. Is one more student with not here? Okay. Now we complete. We are complete now. Okay. So first of all, before we start our lesson for today, I'd like to thanks to you for the weekly task for chemistry, especially. Did you got your score? All of them, right? Not only chemistry. You see all the score. Very good. For chemistry, again, I would like to thanks for the good result because I see in general, in average, it was good. So from this one, I will conclude that all of you has already understood about oxidation number and how to balance the redox reaction. And as I told you that before, that topics is the foundation to study about electrochemistry. Today we are going to enter about electrochemistry. Yeah, we start with simple things, and then maybe we are going to spend 2 or 3 weeks to finish this electrochemistry things. So just be ready because this is a very broad topic. There are so many things that we are going to see in this electrochemistry. All right, let's start with the question. Let's start with the question. We learned about redox last week, and today we are going to learn about electrochemistry. And I told you that electrochemistry is related with electricity. So how can you connect the redox with the electricity? Is there any relation, connection between redox and electricity? Anyone want to give some opinion about this? Yes, Ilham, please.
Sir, I think the relation between oxidation and electron is because the oxidation, the oxidate can be the relation of electron, and the reduction is gain of electron.
All right. So when you have a redox reaction, reduction and oxidation, there will be a transfer of electron, isn't it? Movement of electron in reduction and oxidation. And we know that electricity is actually the movement of the electron. There is a current of electricity because of the movement of the electron. So that's why there is a connection there. When we have a movement of electron, then there will be an electricity, and the movement of electron is happening in redox, right? So this is the connection between them. All right, thank you very much. So everyone is understood, I think, about this. All right, now let me show you my whiteboard. Today the connection is very bad, isn't it? Sometimes I difficult to write here because of the connection. Inshallah, now it is good. Yeah, it starts to be slower again, becomes slower now. All right, we learn about electrochemistry today. Okay, so as the name, there will be a flowing of electron, you see, in a redox reaction, flowing electron in redox, yeah. And this flowing of electron will make a current, electricity. What do you think? What will be the direction of the flowing of electron and the direction of the current? Are they the same in the same direction or a different direction? What do you think? We have a flowing of electron and we have a current in electricity. Are they in the same direction or somehow it is an opposite direction? What do you think? Yes? No idea? Yes, Adi?
I think they have a different direction.
All right.
For flowing electron in redox, for flowing electron, the electron move from the high electron to the less electron. For the current,
Right.
the movement or apa ya, lupa itu, gerak apa, arah aliran dari positif ke negatif.
Right. Let's see from that point of view. You said that current of electricity is a movement of electron, movement of current from positive to negative, isn't it? So in redox, somehow it is an opposite. In redox, the electron will move from negative to the positive. So this is the difference. Yeah, from negative to positive, the movement of the electron. All right. Now let's go in deep with this, what we call as electrochemistry. In electrochemistry, we are going to have a cell, yeah. What do you understand about the cell? Of course, this is not the cell in biology. The cell is a place. Misalnya sel tahanan itu kan itu tempat tahanan artinya. Cell is a place. Actually in biology, cell is also meaning the place, right? The place where this flowing of electron and current is going on in a reaction, we call that one in electrochemistry as electrochemical cell. Okay, the name of the cell is this, electrochemical cell. So this electrochemical cell is the place where we can see the flowing of electron and current. So it is a very, very important cell in learning about electrochemistry. We have two types of electrochemical cell. The first type we call as a Voltaic cell. Sometime in some of the book they say it was a galvanic cell, no problem, Voltaic or galvanic cell. And the second we call as the electrolytic cell. Okay, electrolytic cell, Voltaic cell and electrolytic cell. How can we differentiate between these two cells? It's very easy, simple. To differentiate between these two cells, we just see the electricity in the cell. Yeah, if the electricity is produced, then it is a voltaic cell. Electricity produced, then it is a voltaic cell. But if electricity is used, Then it is electrolytic cell. So we have two important words here, produce and use. Some of the electricity will be produced and some of them will be used. If it is produced, then voltaic cell. If it is used, electrolytic cell. All right. Can you give me an example about electricity produced? What things that can produce electricity? Of course, we are still talking about electrochemical cell in our life. Can you give me an example here? Think about our surrounding. Is there any things that can produce electricity and is using chemical chemical reaction inside? The reaction must be redox. Yes, very simple. Just think a little bit for your surrounding. No one can give example? Come on, guys. Just say something. Agus, do you want to say something?
I think battery, sir.
What?
Battery.
Battery, very good. Very good example. What else? Battery is using chemical reaction there, redox reaction.
Aki.
Right, very good. Accumulator is also one of the example. All right, now let's give example about electrolytic cell. Is somehow more difficult than the example of voltaic cell because electricity, electrolytic cell is not common in our life. For example, let me give you the example, plating. You know plating? Penyepuhan. Do you know penyepuhan? Penyepuhan emas, penyepuhan perak. Do you know ya? Have you heard about that? Penyepuhan emas, nggak pernah dengar? And never heard that. Gold plating, silver plating. So you plat for example, you had a ring, yeah. You want to make it good, so you plat with the gold. This is gold plating. Or for example, you have iron, then you want to protect the iron, then you can protect the iron from the corrosion by using the plating also, penyepuhan ya. So this is also one example of the electrolytic cell in plating process, because in plating you're going to use electricity. And also, for example, in electrolysis, yes, this is a very important process. Electrolysis, we're going to see in detail about this later on at the end of this chapter. One of the topic is electrolysis. We're going to see in detail about this. All right. Now, okay, I'm going to show you, but before showing you the video, I'm going to show you a video. Let's proceed first with the voltaic cell. First, I'm going to explain this voltaic cell, yeah, electrolytic cell in the second part. But I think this week we are going to talk about only this voltaic cell because there are so many things that you have to learn in here. Next week, maybe we're going to continue with electrolytic cell. I hope I could finish it in 1 week, Voltaic Cell, because there are so many things that we have to learn. We're going to start our journey of Voltaic Cell in here. Remember, when we're talking about Voltaic Cell, we are producing electricity. So it's very important. We are producing electricity in here. All right, one of the most common characteristic of Voltaic Cell is the reaction must be spontaneous. Do you know spontaneous? What does it mean, spontaneous? Spontan. So it's happened by itself. Yeah. Spontaneous means happening by itself without any disturbing or helping from the outside. The reaction can happen itself. It's meant as spontaneous. All right. I'm going to show you this spontaneous example of spontaneous reaction here by using a video. The video will show you the reaction between zinc, reacted with the copper, but the copper is in the solution. Yeah. In the video, we are going to see that the copper is in copper sulfate solution. And we're going to see what happened in the reaction. Let's watch the video. All right. All right, I'm going to share first the video. Our video. Hey guys, we have zinc here, zinc solid, yeah, a bar of zinc in a zinc, and we have copper sulfate solution here. The blue solution is the copper sulfate solution. Inside there are copper ions, copper 2+, copper aqueous, yeah, copper 2+ ion here in the solution. Let's see what happened when we react these two things. See? You see, yeah? Of course, this reaction is not as fast as this one. This has become, the video is faster, but it's more slowly must be the reaction. But as you can see here, what happened? Now the zinc is covered with this dark material here. And this dark material is actually is the copper that accumulated from the solution. Copper accumulated from the solution. So it's become copper solid here. So copper from solution become copper solid. So what happened actually in the reaction? Let me show you by whiteboard. Actually, zinc, normally zinc is solid. When you put it to copper solution, zinc will become zinc ion, zinc 2+. You will not see this zinc 2+ because it is immersed in the solution. Yeah. But at the same time, copper will become accumulated as a solid. That dark accumulation, dark platted in this zinc is actually the copper. Okay. So here happening redox reaction, as you can see, guys, zinc oxidize here, copper reduce here. So there is a redox reaction here, and the redox reaction is going on spontaneously. And that's why this reaction can happen in Voltaic cell. Okay, is it clear? Okay, let's check up to here. Is it clear or not? All right, Ivan, what do you understand up to here? Can you tell me something? You can use Bahasa if you want. We couldn't hear you. The microphone is too noisy. Hello?
Halo.
Yes, now you can say something.
Sejauh ini yang belum didapatkan tadi baru di pengertian tentang Voltaic Cell, dan ini mau kasih memahami yang penting dan kebarusan.
Okay, can you explain a little bit about the Voltaic cell?
Voltaic Cell tadi dia bereaksi secara spontan dan yang sendiri itu produce dan that's all.
Right. I get that it's spontan, he said. Okay, let me ask Rian. Rian, what do you understand up to here, Rian? Yes.
I think Volta is mengubah energi kimia menjadi energi listrik.
All right. So it's produce electricity from that one. Okay. And then, what do you understand from the video? You're still muted.
Elektron dari logam zinc ditangkap oleh Cu2+-nya.
All right, thank you. Very good. More deeper, actually, deeper than what the video said. Thank you very much. Eza. Oh, Eza, how are you, Eza? Are you okay, Eza? This has been so long.
Thank you for asking.
I didn't get any information from you. Are you okay?
Alhamdulillah, okay, sir. Thank you for asking.
Okay, what do you understand from the video?
From the video that, like you said, the reaction is spontaneous, and I think I wrote down my note wrongly because the redox that I wrote down is quite not match what Rian said. So I'm not a little bit confused because the information that I got may be split up.
How do you get the note?
From the note, I think I wrote it wrongly, but in my note that I wrote, the zinc is doing a oxidation and the copper doing a reduction.
That's true. The zinc is oxidized there, and the copper is reduced. Right?
So I wrote it correctly. Alhamdulillah.
Let's see. The zinc is oxidized here, isn't it? The zinc is oxidized, and the copper is reduced, isn't it? All right. Now, let's proceed with another things. Okay, I have this reaction. How about this reaction? I'm sorry, it is too, let me read it a little bit more left. How about this reaction? If I react zinc, sorry. Not zinc, copper. I mean, I reverse the reaction. If I do this copper solid, I immerse into zinc solution, do this reaction will happen? I mean the reverse of the first reaction. What do you think? Any opinion about this? Farhan, do you have any opinion?
I think no, sorry.
Why no?
Because the first reaction is producing electricity.
Yes.
So the kalau
You can use bahasa.
if we want to reverse the reaction, we need some electricity to make it occur.
So it is non-spontaneous, you mean?
Yes.
All right. Thank you. Very good analysis. So if the first reaction is spontaneous, Farhan said the second reaction, it mustn't be happen directly. You need electricity, he said, and that's why it is non-spontaneous. Okay, let's watch again a video to answer the question. I'll give you another video. No disclaimer on the video. All right.
Remember that redox reactions are spontaneous in only one direction. Here we have an example of one spontaneous and one non-spontaneous redox reaction. First, we have the reaction of zinc metal with copper ion, then the reaction of copper metal with zinc ion.
Okay, the left reaction is the reaction that we see before, and we know already the answer, yeah? When zinc is immersed in the copper sulfate solution, there will be a spontaneous reaction where zinc will oxidize, copper will reduce, and you will get an accumulated of copper in the zinc, the dark accumulation, right? Now the question is our second one here. When copper is immersed in the zinc solution is colorless like this, and we're going to put copper bar into this solution. We are going to immerse it, and we're going to see what will happen.
Let's see which one is spontaneous. As you can see, the zinc metal turned dark due to the formation of solid copper on the surface.
As you can see, there is a dark accumulation solid of copper here as we wrote the reaction like this. Here, nothing happened, right? In here, nothing happened. So that's why the reverse reaction is actually a non-spontaneous reaction. So it will not make a reaction. All right? Is it clear now? Clear, yeah? So, we can say that this reaction will not happening. No reaction, or it is non-spontaneous, we can say. All right. Is it clear up to here? Right. Can I erase all of this? All right. I will erase all of them. All right. Now, after we know about spontaneous and non-spontaneous, things. In Voltaic cell, we say that it is a spontaneous reaction. Now, in this next things, we are going to learn how the Voltaic cell is working, how the Voltaic cell will produce electricity. Okay, so our next thing is we're going to see how the Voltaic cell is work. I mean, what installment that you're going to make the Voltaic cell working? I mean, it will produce electricity. We know that Voltaic cell. So how it produces electricity? This is what we are going to see. And I'm going to show you another video for this. All right. We're going to watch the video, and then if we have time, we are going to continue. If not, in the second hour, we're going to explain about the video. Let me open the video first. All right.
When a strip of zinc metal is immersed in an aqueous copper 2 sulfate solution.
This is the reaction that we see, copper plus zinc sulfate, yeah? Zinc plus copper sulfate. And we see this reaction, and we know that it's a spontaneous reaction. The copper will be plated with the dark accumulation of copper.
Electrons are transferred from zinc to the copper 2 ions. Copper metal deposits on the zinc strip and collects at the bottom of the flask. Zinc atoms are oxidized to zinc 2 ions, which enter the solution. This spontaneous oxidation reduction reaction is summarized in the chemical.
This is the summarize of the reaction. We know that one, zinc plus copper becomes zinc 2 plus copper. So there's oxidation and reduction reaction here.
Chemical equation shown. The spontaneous copper-zinc oxidation reduction reaction.
Right, this is the important thing here. To know how the Voltaic cell is work or not, or how the Voltaic cell is work, we're going to install a kind of circuit like this. So it will be a little bit different. Here again, I'm using zinc and copper. Yeah, zinc in the left side, copper in the right side. And in the solution, I will have zinc solution here, copper solution here.
Can be made to yield useful electrical work by incorporating it in a Voltaic cell. The zinc electrode is immersed in a solution of zinc sulfate. The copper electrode is immersed in a solution of copper 2 sulfate.
So don't be confused. Zinc will be immersed in zinc solution, and copper will be immersed in copper solution. Zinc sama zinc, copper and copper. This is how to install the Voltaic cell to make the circuit is working. So we are going to produce electricity from here. Yeah, zinc immersed in the zinc solution, copper immersed in the copper, not the vice versa, not zinc in copper or copper in zinc, no, but zinc in zinc, copper in copper.
No current flows through the light bulb because the electrical circuit is not complete.
Now, before we add that one, in this condition, this circuit is open circuit, so it will not produce any electricity. What does it mean open circuit? As you can see, the circuit can flow from here to here, but there is no flowing from here to here. From the big pair, there is no other flowing. So it's like an open circuit. It is not a closed circuit. If the circuit is open, of course, there will be no electricity. So we have to close it by using one equipment.
To complete the electrical circuit, we add a tubular bridge filled with aqueous sodium sulfate solution with a pore.
Okay, to close the system, we use this equipment. We call this one as a salt bridge, jembatan garam, salt bridge. This is like a bridge between two beakers, and inside this salt bit there is salt solution, salty solution. In this example, the salty solution is Na2SO4, which is containing iron. We know that salt is containing iron, sodium plus iron, and sulfate negative ion. We're going to see this ion, what is the role of this ion in this circuit at the end.
Plug on each end. We now have a complete circuit and current flows. When we replace the light bulb with a voltmeter,
Okay, when you replace the light bulbs, bulb is become lighting. Yeah, when we have this complete circuit, when you replace it with voltmeter, you're going to see that the voltmeter will show you 1.1. It's mean that this circuit is producing 1.1 volt electricity.
We find that the cell has a potential or voltage of 1.1 volts. The copper electrode is the positive electrode, and the zinc electrode is the negative electrode. As the cell reaction proceeds, zinc atoms of the zinc electrode lose electrons and move into the solution as zinc ions. At the same time, copper 2 ions acquire electrons at the copper electrode and form copper metal. The reaction in the left-hand compartment is oxidation of zinc.
So what happened here in the left side, zinc electrode will release electron. As you can see from the reaction, zinc electrode release electron here, and the electron will goes to these wires, go to the copper electrode. And this electron will be captured by this copper 2+ ion, and the copper 2+ will reduce, after captured electron will reduce to copper. So there will be a deposit of copper here inside this electrode. This is how the electron is moved. So from here, zinc is oxidized, giving electron to the circuit, and go to here the electron captured by the copper 2+ and deposit the copper here. So there is a flowing of electron in the circuit.
Electrode at which oxidation occurs is called the anode. The reaction in the right-hand compartment is reduction of copper. The electrode at which reduction occurs is called the cathode.
All right, we can give the name of the electrode here. The place where the oxidation is occurring. Here is oxidation, right? Zinc is oxidized. The place where oxidation is occurring is anode. And the place where reduction occurring, it is called cathode. Okay, anode, oxidation occurring, cathode, reduction occurring. We have to stop in here. In the second hour, we're going to continue with this video. Now, let's stop in here. Have a nice lunch, and welcome. We're going to meet again in the second hour. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, sir.